Hello, people. Good afternoon, good morning, good night, all that good stuff. Let me talk to you quickly about the and this rebar, right? Little whips, if you will, like a whip, like a utility whip. There's another one at the bottom down there, and they were here at one time inside the deck, not to be confused with the topping inside the structural deck. They were. So let's back this up and let's do this. So they were inside here. Whoa. Okay, I messed that up. And get rid of that and do that. Alright, so they were inside there. Inside here, out to the deck. The deck was on it like that. And there we go. Okay, so now the whip down here. This is that little... Okay, let me grab the marker again. So here's your little whip, the rebar, the reinforcement. Now, you see the full piece of it, so that went like that, more than likely missing the column here. So it was on the outside of it. Let's go forward now. I'll leave that one there so you can see it. And I want you to think of that reinforcement inside the deck here. So it went like that. The deflection of the deck is countered by, remember I talk about the bottom parts in compression, even though they tell you it's in tension only, right? It's compression over here. The reinforcement, let me back up two of those for you, one of them. So the reinforcement is through this. As I look at this steel, I look at the edges, tips of them, if you will, the tips that are left. And I see what appears to be white paste, the bonding Portland cement to the steel. As I look at the other part of the steel, I really don't see that. It's hit and miss on a few of these, but let's now superimpose that over the slab right here. So here's a concrete there, and there's a concrete there. All right, so then I get concrete here. I get a paste in here. This is the column. But in this section here, I get holidays. I get nothing. I don't get a grip. I don't get the grip, the bond that should be taking place to help with all the loads coming down. The development length is ultimately just this little piece here. This offset anchor, if you will. The anchor's further back, instead of it all being an anchor, if you will. So now there's just that part there. So as this deflects, the bar, this does have a concrete interface, if you will. It's all one piece, but that easily fractures, and you never see it because of the overlay is on top of it. The overlay of the material, so you don't see what's going on there. Now let's back that up. So we get this deflection over here with the cars, and it's creating a stress over here because this is really not bonding. This section in here is not bonding, and you get the grip on this end and down here. When it fails, let's back all this up now. When it fails, it just unzips the top of it. It breaks the top of the concrete off. So let's do this, and let's do this. So as it's failing, just trying to get a little, I'm trying to do a little 3D for you, if you will, a little two-dimensional. There are anchors here, and the anchors here. The bar doesn't get any longer, doesn't elongate, so it starts ripping off the top of that slab. And I'm going to take a little liberty. Take a little liberty here. I'm going to do a slab, and I'm going to double back like that's the rebar, and you're going to see the slab, right? So that's the slab, and this is the rebar in it right here. And as that rebar, as the deck deflects, it's able to spall off that section there, spall off a little bit more. Ultimately, to when it's down just to the anchor, this stuff just spalls off. We look at it, and it deflects off, it displaces off, it ejects off All right, so there is the topping slab right here, the stamped concrete. I say it ejects off. This is a piece that was, this piece here was up here, but it was covered with the pavement, the stamped concrete. That is not stamped concrete turned over any or any direction. This is part of this concrete, the structural slab. I can extrapolate that because another part of the deck on the south wall has the same debris field that came off the back wall, and it's sitting on the deck right next to a planter box. It's a piece that comes right underneath the column KL, maybe under L, right about there. It's also ejected off and flipped in the air as this goes down, and then comes the rest here. That's what I'm guessing, that the timing is there, or it bounces down and the rest comes the rest there. When I say bounce, so elastic, doop, collision, elastic collision, doop, 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 and comes the rest there. Inelastic, no, so it's elastic, doop, 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 rest, or doop in the air time, and it goes down with the deck and bounces over to there. I think it had a little air time. Okay, so these are probably the equivalent. These little guys here are probably had some steel that was supposed to be tied into it. It's not in the mid-span. The connection. The connection is at the if you will, the compressive side of that, as I call it, the bottom half. So it still couldn't hold up. It's not enough development, not enough bond that goes all the way down into the bottom of the deck. It's like that. If you can imagine this rebar's in there, and let's back this up. As they were building it, they probably had it like that, and that's this little ear here, times 2, coming over to this direction, and that's because we can see it on the face of this column. All right, so the deck, when it deflects, it can't, even if they have steel here, it's not enough overlap and bond to hold, to even help it probably helped for some time, but ultimately the deflection starts taking place, and these two become unengaged right there. And let's see now. This one is the one that, as the deck's going down, it just happens to go across the ears here and profile like that, because it now was stretched a little bit up top. Up top it was like this. All right, so it was out here too, outside of the column, or it was this. Let me do this right there, and so it took a ride down, and it looks like it scratched right about here where it came, where it moved over to the right towards this area, and then as the deck settled, it came back, so right about here, and then scratched down and came the rest there. It might be in here. If not, that tells me my butterfly happened a little bit to break this side of the deck and this side of the deck. It gets us that elongation, because somewhere, when I say elongation, I don't mean that it's stretched. I mean the deformed because of, or it's the way it's shaped now, because it released from one side of the deck. It either released from here or it released from there. So I'd have to look at both sides a little more in depth to figure out which side it released from. But I can extrapolate through other sources. Again, so we look at this, and now we see that just that reinforcement just has some paste there, and this appears to be lacking paste. So that's that same. Think of it like an anchor point further away, and it's a little bit of bond instead of continuous bond that would help with the with its rigidity there. Would help with its rigidity, because I see it as the top steel is acting as a negative steel, and you can also think of it, make it easier for you to think of it. Oh, it's in a cantilever action, and then the bottom steel is around mid-span takes care of it would come over. I know I hate giving away some of my goodies, but let's do this again. The reason why, because it seems like I'm talking to nobody. It's only a few people now that can follow the content via shadow ban. Welcome. So so let's just use that as let's use this column literally. Let's use this column. So here's the steel here. There's the top steel. And it seems like it had the right amount of development to be top steel. It looks like the steel would come, way over here, 5 foot over, and there's like a 20-foot span, or I think 20 something like that. About a quarter of the way is what I'm looking for. And it seems like that did it, except for it only had that little bit of bond, the little bit of marriage. So it had the top steel and the bottom steel. Well, there's a little piece, and I can't tell what else is there, but it appears that they did their overlap way at the wall there, which would be nice, except for this guy so small. They could have overlapped that bottom steel across it while they were still doing the deck, but steel's money, and I guess they decided to do not, and they probably just did the head first, and that's not going to, and it didn't happen there. So as you look at the other columns, you're going to be looking again for the steel and this reinforcement. Let me pause the video. So on this side, by the planter box and the vehicle parking, we see good paste. Look at that. Well, we see paste. It's good paste, good coverage there. Maybe here, I can't quite tell here. Other photographs too, but I'm just using this one. Now you might wonder about this steel. This steel might have just lost its bond strength inside here and just spun to this position because the others aren't supporting that. This side is not supporting that rotation, that rotation, because this one's like that, and I don't have it as one piece breaking off and doing that. The top concrete, what do you call it, the overlay might have ground that and threw it over there. But now I'm going to show you something else. Let's get rid of that. This is where when it collapsed, and here, when it collapsed, this area in here, you see the grind? This is where it initially took a moment to grind into it, and then the other side fought back, broke free, and neither one could touch the surfaces at that point. And this is where you get the release, no materials rubbing. As you look around the column there, it looks pretty consistent, doesn't it? Maybe some stray pieces there. This could be the flap down there. If the flap was like that, it could have resulted in that. Or this could just be loose. It could have just spun around and just be loose. I can't quite make out if it's, I can't be sure if it's at the bottom down here or if it's this one. I can't make it out. It sort of corrupts my vision there a bit. Or is it multiple pieces? I do see in the back there's some good bond. It looks bond of concrete again here. This looks like it's absent, but this looks nice. This looks pretty much absent. This one looks pretty much black. I've already showed you this fracture here, and that's your typical punch shearing layout. Looks like that. When you've got your rebar, your pads like this, and your top steel and your bottom steel, and that's what this looks like here. Saved, I don't see the bottom steel on the real imagery. It doesn't mean it's not there. Remember, as this comes away, it could pop the bottom steel. And I know Miami Herald and everyone else is like, it doesn't have it. Well, it could have just popped it, and we don't see it until you get close up. And then you see a little hole where it was, a little dot. Or no, they would have had these like this. There's the one there. So these could have popped it, and they would hide themselves like that. Let me get you some more. So as we look into this image here, you see the yeah. Okay, so you see this the stamped concrete Well, there's a piece of rebar right there. It looks like right there. And this is where it probably goes up. Remember, this is on this side. That rebar is probably resting against this column here like that. This column, not 72, but the other side of it. And it's holding up this flap. So if that's the case, that tells you that it slipped out. But wait a minute, so then that's just a theory as I look at it. I'm telling you the way it works, the way I process. And then I go, let's prove that. And then, hold on. So I'm like, let's prove that. And I look deeper into the image and I'm like, oh, here they are up here. And this one. So what's keeping this up in the air is the question. So what's keeping that, just this topping in the air? That's a question. And I'm like, okay, I got to resolve that. Not in this video. But we see that the steel here again, same thing. And you can see this one disengaged way up here. And then the other left, the steel closest to us, or appear presents as closest to us, it held on longer as this pad went down and released this. This we had to get out of the way. So at one point this is probably like that, and then fell forward to its resting point here, this flap, hinging here. But this tells you the story of how the rebar tells you the story about how it went to failure. This one released first. It didn't release down here and go boing and spring back up. It's not spring metal. This rebar does not bend back like that. It doesn't spring back. It has a little bit of recovery, very slight. On the smaller pieces especially, the longer pieces like this, no. All right, so meaning, so you spring it that much and it might spring back, that much. It's not much at all. But again, this piece tells you that when the deck went down, this piece released all the way up here. So it definitely didn't have a bond. It just broke free. I don't see the rubbing over here. So the fracture was differently, right? So let's back this off. Let me pause the video. So I'll end the video with this imagery. This is the overlay material. The overlay has some bottom steel in it, some steel in it that's rusty pretty significantly. There's a little bit of a sand bed, and there's a tile, and there's a rebar in the background. There's a column here. There's the rebar in the background, and you can see that it doesn't really have paste engagement. It can grind off because as this failed, this would have grinded, and it didn't. You don't see the paste there. So this supports what I'm talking about, where the antennas have a little bit of paste there, anchorage there, and because they're still in the bottom deck, we'll see that this side, one side had the anchorage that stayed, the other side of the columns had the anchorage that released. That anchorage released, and this goes over the head part. That in that case, with that modeling for you. I'm going to end the video. Hope you guys like the content, and I have more details to give, but I'm playing it light. All right, take care. Bye.